Wiring a large, complex language model directly into your highly structured enterprise APIs is a massive security vulnerability. AI agents require access to external tools to execute tasks, yet their underlying reasoning mechanisms are entirely probabilistic. Probabilistic reasoning means the model mathematically guesses the next best sequence of outputs based on patterns. Strict access controls require absolute, uncompromising certainty. Allowing an LLM to autonomously decide when and how to format a call to an internal database leaves the network exposed to unpredictable inputs. Without a rigid structural boundary between the model's text generation and your infrastructure, the security risks are unacceptable. A common engineering approach attempts to solve this by embedding strict lists of allowed tools directly into the agent system prompt. These prompt constraints fail when the model encounters adversarial prompt injection or simply hallucinates a completely non-existent tool parameter. Even secondary application-side code checks fall short because they assume the model will eventually generate an expected, parsable output. A secure architecture requires completely decoupling the authorization boundary from the agent's internal logic. Amazon Bedrock AgentCore provides the infrastructure to execute this physical separation at scale. AgentCore routes every intended tool interaction away from the model and through a centralized deterministic gateway. This gateway is governed by Cedar, an open-source, mathematically verifiable policy language. Security controls must exist as a deterministic checkpoint outside the probabilistic environment. We can map this architecture starting from the baseline environment. Here is the AgentCore runtime, a secure, serverless environment for dynamic AI workloads. Developers plug in frameworks like LangGraph or Crew AI alongside foundation models. This completely isolates open-source deployments. Developers get session isolation and persistent memory out of the box without managing underlying infrastructure. While the runtime secures internal reasoning loops, the agent still needs a way to safely reach the outside world to execute real tasks. The runtime guarantees internal execution stability. The next step is controlling external access. Agents need to execute workflows across external services like Salesforce, Jira, or custom AWS Lambda functions. The AgentCore Gateway serves as the strict translation and enforcement layer between the isolated runtime and those external APIs. Instead of writing custom integration code, the gateway wraps existing APIs and backend functions into standard Model Context Protocol, or MCP, compatible tools. Watch an agent attempt to use a tool. It dispatches a data packet containing the requested action, but hits a hard boundary at the gateway. The request is completely halted. The gateway extracts the user identity and tool parameters from the suspended packet. The gateway physically separates what the agent intends to do from the actual execution of that intent. The decision to allow or block the halted request is made by a policy engine sitting directly at this gateway boundary. This engine uses Cedar to evaluate requests against the PARC authorization model: principal, action, resource, and context. This block of Cedar code explicitly defines the conditions for approval. The permit effect establishes an allow list rule. The principal variable authorizes the user Alice. The action and resource variables restrict her solely to updating a specific file named Vacation Photo 94. The PARC model translates abstract business rules into unambiguous, executable constraints. The evaluation engine executing these rules is stateless, written in Rust, and optimized to return decisions with bounded latency. This Rust snippet shows inputs routing directly into the authorizer. Intercepted request details and the Cedar policy set pass simultaneously into the authorization function. The logic applies a mathematical rule. The action proceeds only if there's a matching permit and 0 forbid statements. Developers can write these rules natively in Cedar or use AgentCore's natural language engine to generate and validate safety conditions directly against the tool schema. Stateless evaluation provides deterministic security guarantees without degrading the real-time speed of the agent. At enterprise scale, this architecture must handle thousands of concurrent agent requests. High-speed data packets flow in and are rapidly evaluated, sorting cleanly into approved execution channels or rejected bins. The system natively logs every single policy decision, recording the exact conditions of both successful permits and blocked forbids. These logs integrate directly with Amazon CloudWatch and emit telemetry data in standardized open telemetry formats. DevSecOps teams gain a complete, auditable trace of every execution path and boundary failure. Amazon Bedrock AgentCore solves AI security by moving authorization entirely out of the probabilistic model and into deterministic infrastructure. Decoupling logic from security allows developers to scale agents securely using any open-source framework. Offloading the complexities of access control to the gateway drastically accelerates the delivery of agent-powered applications into production. AgentCore handles the strict compliance requirements, leaving engineers free to build smarter, more capable AI workflows.